So the next one is a plane. And looking at the plane here, what I see on my plane is I have 3 points. Here's a capital letter K, J, and L. And then, so those are my points on the plane. So you need at least 3 points on the plane in order to make it a plane. If you don't have 3 points, if you only have 2 points, then it's a line. So I can name my plane with 3 letters here. So here I have plane JKL, I have plane KLKJ, and I have plane KLJ. So the order doesn't matter again. And up in the corner here, I have a capital letter, and it's an S. So that's not a point. That is not a point up there. It's just an S. It's the name of the plane. So I would say that is plane S. So if I had another point right down here, we call this F. Point F is not on that plane. It would create another plane if it had 3 more points to it. So point F is below that plane. Okay, so we already talked about the coordinate plane, and again, we use lowercase letters. Okay, so the next thing I'm going to talk about are a line segment and array. So a line segment is just part of the line. And so here I have segment CD, and I have endpoints right here. So here's an endpoint, and there's an endpoint. I mean, that contains the line. CD is just the length between these 2 points. And to name a segment, I use the segment bar now. So, and again, I name it with 2 points, CD, or I can name it DC. Again, the order does not matter. So this is what a line looks like. So if I added the arrowheads, so now I'm making it a line. So I added the arrowheads and I put the notation for a line up here. So now this is a line. So I'm talking about CD, the line that goes on and on and on and on, and it never ends. The segment, I'm just talking about part of it. So it's a line segment, it's part of the line. All right, the next thing that a lot of you have problems with is this notation. So, and understanding what array is. And I really like someone's analogy when I said, go find a picture. You went and found a picture of the sun and you made that the point where it begins and you drew the rays in there, and I thought that was fabulous. So that's what array is. It's a starting point. There's a starting point, and that's called an endpoint. And so this is always where it starts. So we know the rays from the sun start at the sun and come down to the earth. So we always start at when we name it, we always start at the endpoint. So it starts at R and it goes through S. And I know the ray, I'm going to use the notation for array, and I always make that, I make it go left to right because we read left to right. So my next ray here, so I have, it starts at A, so you see here's my endpoint, it starts at A, so that letter has to come first. And then it goes through, so it goes through B. And again, even though the ray is pointing to the right, the notation the ray is pointing to the left, the notation goes left to right. So the notation is always the same. Okay, so we're going to practice this. So if you need to, this is the part that's extra. So you can go ahead and draw your line here and put your points on it. And we're just going to practice naming rays and what opposite rays are. Okay, because again, on that paper that I uploaded all the answers to. So you need to go in and look at those answers and compare them to what you did and figure out what you did wrong. All right, I'm not going to take that paper for a regrade because I uploaded the answers, but it would be in your best interest to figure out what you did wrong. Okay, so would everybody just type your name, your first name in the chat right now, just so I have it for the roll, because I didn't take roll. Thanks. All right. Okay, so looking at my array here, I have a lot of collinear points. So K and B and A and C, they're all collinear. They're on the same line. So what this is asking me to do is I want to name 4 arrays within point A. So that means these 4 arrays have the same endpoint. So that's going to always be my starting point. I'm always going to start at A. So I start at A and I go this way. So I went through C. So that's going to be 1 array. So do you see also when I go through C, I go through E as well because it keeps going on and on and on. So AE are actually the same array. I just named it 2 different ways. Now if I take and start at A again and I go to the left, again I go, my first point I come to is B. So that is ray AB. But the same ray, all right, if I keep going, I go through K. So the AK is the same ray. So I started each time at that endpoint, and then I went through the other points. So that's how you name a ray. Now, when it says a pair of opposite rays, so what I know is that blue line that I drew and the red line, they're all on the same line, and they are opposite rays. So opposite rays they share an endpoint. So if I say AE, and that's my blue one, is in the opposite ray, so AE, and I can say AB, and that was my red one. So those are opposite rays. That's 1 pair of opposite rays. I can name another pair of opposite rays. So if I say C, and that was the blue one, and K. So that is 1 red, 1 blue. So that's a pair of opposite rays as well. And then I can say AC, my blue one. AC is my blue one. And then I just need to name another one for the red one. So AC, I already said AK. So I'm going to say AB. So I just named 3 pairs of opposite rays. So there's probably 1 more in there as well. So if I did B, AB, and AK. So opposite rays, they're on the same line. They go in opposite directions. I know they're rays because of the notation here. So that notation tells me they're a ray. And it's very important that you understand the notation for array, because you're going to take a quiz and it's going to say, name a pair of opposite rays, name a line, name a point, name a plane. So, and that's not you writing out the word ray, all right? You're not writing ray AE. you're using the notation for that ray. The only time you write the words out is with plain and a point. And that's what I want to see. All right, so this was in the video as well, and I just want to kind of review it. So how many dimensions does a point have? So a point is 0-dimensional. So it's just some time, so a point in time. So it has no dimensions. A line is 1-dimensional. So you can see it's just a straight line. And a 2-dimensional shape is our triangle, rectangle, so it has length and width. 3-dimensional has height. All right, collinear and coplanar was on the video as well. So again, these vocabularies are essential, or I would not be going over them again. You need to know the vocab. So coplanar, once again, just mean points on the same plane. So I can see that A, B, C are coplanar points. They're points on the same plane. And they're non-collinear. Collinear are points on the same line. So I know A, B, C, and D, they're all on the same line. That's collinear. And then parallel, and some of you did not do exactly what I did when you're doing the vocab. I don't know if I went through and graded them. I think I did. But you need to make sure that you're doing the notation correctly. So I know I have line, and that's what I have here, line AB, and it's parallel to line CD. I have the little notations for parallel, so I know that they're parallel. I know they're lines because they go on and on and on. And so if you're drawing a line, you have to put the arrowheads on there. Another thing, another way to name these parallel lines is by the lowercase letters. I gave a lowercase m and a lowercase n, and I just put it right over here, and I just wrote it as m is parallel to n. And this is just how you read it. Line AB is parallel to line CD. So that's just reading it. This is new, this next part, so you probably should write this down. Time 7:30. Okay, so you need to know the difference between a postulate and a theorem. And so this postulate below it, we're about to go over it in just a moment. A postulate is just a statement that's accepted as truth. No one has proven it. The Pythagorean theorem is a theorem. Someone came along and they did a big proof on it. And so just to justify that what we're saying is true. So a postulate or axiom is another word for postulate, is a statement accepted as truth. So, and this is one postulate. So they're saying if I know the length of AB and I know the length of BC, if I add those two together, that's going to equal the total length. And someone came up with that idea and everybody goes, oh yeah, I agree, that's truth. So that's a postulate. That's why we name it a postulate. All right, so let's go to the next idea. All right, so this is our So this is segment addition postulate. So that's what this is. So you're going to just put these in your notes. And you have that on the other page, so you don't need it on the top of yours because you hope, well, maybe you don't. I don't know if you're taking notes or not. So what I know here is, so you're always going to start off by writing that statement that we had on the other page. So I know that JK here plus KL, and this is my symbolic notation that's so important, is equal to JL. So I know that this is the information I have. So JK, then now I'm just going to use substitution. So JK is 2 and KL is 7, and that's what JL equals. So 7 plus 2. So I know JL equals 9 units. So I'm just going to answer the question. So it's 9 units. And now on number 4, I'm just going to do the same thing. So looking at the picture, I know that AB plus BC equals AC. So now I'm going to substitute in. So AB is 6, BC is 12, and I know that's what AC equals. So this is 18. So AC is 18, and it's 18 can mean anything. So that's why you need to write the word units. Again, this is segment addition postulate. Probably. So I'm going to upload the notes so you can go on and get them from Google Classroom if you didn't write this down. Okay, so let's talk about, this is now the ruler postulate, and we actually have used this a lot with slope. You probably didn't realize it was such a postulate, but it is. Again, this is new, so you probably should write this down. So when we use the ruler postulate, we're always going to use the absolute value. And so if I have a point A, and this is point B, what it says is we know that if I can say A minus B, all right, is going to be equal to a positive number. Okay, it's always going to be a positive number because the absolute value is always positive. So, or I can say B minus A, and that is going to be a positive number as well. So let's just do the 2 examples here. So A I have is 11. So I'm going to say 11 minus 17, and it's the absolute value. So therefore, the numbers are opposite. So I'm going to subtract. So 17 minus 11 is 6. And so this is a negative 6. So remember, distance, the length of something is always positive. So therefore, it comes out to a positive 6. All right. So now on my next one, so I'm just going to say, I said B minus A. So I'm going to say 17 minus 11. And so when I simplify this one, you can see that inside the absolute value, it's a positive 6. So therefore, this is just 6. So the length of that line is 6 units. And I could have counted it 1, 2, 3, 4, 5, 6. But you just need to understand how the length works, right? So we take one point and we subtract the other point from it. That's the length of the line. So how do you know this? You know this through slope. So you know that we take a point of our y value on each of these points and we subtract them from one another, and that's our rise. We take a length of our x value and we subtract them from one another, and that's the run. So these are just lengths, is all they're doing. You're just finding the length between them. And that's why on a graph, we can just, so if the slope comes to, if this comes to 4/3, I know I can count up 4 and over 3. So the slope is just the change in y over the change in x. How is y changing? How is x changing?